So a very good evening everyone. Just confirm me once whether my voice is audible or not. Audio video is clear. Just confirm me once. I am audible, right? Just confirm me once whether my voice is audible or not. Just confirm me whether my voice is audible or not. Audio video is clear. Okay. So a very good evening everyone. I welcome you all to the YouTube platform of IMS GATE Academy. We are here discussing the most excellent questions that are expected in GATE 24. And myself Prateek Mishra, and I am here to discuss about the most excellent questions that are expected in GATE 24 from the subject of environmental engineering. Today we will going to discuss the very important topic from where majority of the questions, n number of questions are asked from this topic, which is the raw water quality parameters, right? If we want to check the quality of water, we check on the basis of these water quality parameters. These water quality parameters are of three types: physical, chemical and biological. There is fixed domain in these raw water quality parameter from where repetitive questions are asked, and we will going to see all those concepts from where majority of the questions you will find in GATE examination. If you just analyze last 20 years question paper, you will find that same concept is repeated for multiple number of times. And today we will going to see all those concepts. So again, I welcome you all and I wish you watch this video till the end, because in the end I have a surprise for you. A brand new question framed by myself just for you viewers. Okay, let's begin the session with this question. Just try this. So this is the question from total solids, right? Total solids comprises of suspended solids and dissolved solids. Suspended solids is a physical water quality parameter and dissolved solids is a chemical water quality parameter. But this question contains total solids. Just read the question and try it for once. I'll give you 1 minute time. And every question we'll attempt, I'll give you 1 minute time to attempt it by yourself. So let's start with this. So here I have a timer for you. This is a 1 minute timer for you. Just try this question. It's a very interesting question. Just try it for once. Okay, let's see this question. Question says that a 50 ml water sample is placed in a dish that weighs 50 grams. So basically you have an empty dish in which you have placed 50 ml of the sample. After evaporation and drying at 104 degrees Celsius and cooling in desiccator, the dish weighs 50.02 grams. Okay. When such type of questions appear in your examination, the first thing is you need to understand what the question is saying, right? If you observe this question is giving you a picture that you have an empty crucible in which you have placed 50 ml of the water sample, Now you place this water sample inside an oven at 104 degrees Celsius. After all the water evaporates, this dish or crucible is only left with the total solids. Okay, so I'll just draw one picture here. This is my crucible, and in this crucible I have placed 50 ml of water sample. 50 ml of water sample I have placed in this crucible. Now this water sample contains both total solids and dissolved solids, right? Okay, this crucible contains total solids, which comprises of suspended solids and dissolved solids. Now this crucible is placed in an oven at 104 degrees Celsius. At this temperature, all the water will evaporate. Now you are only left with crucible and the solids, right? So empty weight of crucible was given as 50 grams. Weight of crucible plus solids is given as 50.02 grams. Is given as 50.02 gram, right? So my step number 1 is calculate the concentration of total solids. So step 1 is to calculate the concentration of total solids. So I will write volume of sample. This is 50 ml. Now empty weight of dish or crucible. Empty weight of dish or crucible. This is given as 50 grams. Next, weight of dish and total solids. Weight of dish and total solids is 50.02 grams. Now this is very easy to calculate. So total solids concentration is equal to weight of total solids plus dish, which is 50.02, minus empty weight of dish, which is 50 gram. Now this is the weight of solid which is present in 50 ml of the sample. So for 1 liter of the sample, it will be divide by 50 and multiply by 1000. So this will going to give you the total solid concentration in gram per liter. This will give you the total solid concentration in gram per liter. Just quickly calculate and tell me the value. Please do the calculation and tell me the value. 50.02 minus 50 divided by 50 into 100. This will going to give me the total solid concentration in gram per liter. So total solid concentration comes out to be total solid concentration comes out to be 0.4 gram per liter. This is my total solid concentration. Okay. Now we will again read the question further. So this is my total solid concentration up to this point. Then the same dish which is oven dried, then the dish is fired at 550 degrees Celsius for 2 hours, and after that it weighs 50.005 gram. So this oven dried dish from where all the water is evaporated, this dish is kept in a muffle furnace at 550 degrees Celsius. This same dish is kept in a muffle furnace at 550 degrees Celsius for the duration of 2 hours. Okay. So when you keep this dish at such a high temperature for such a duration, from this total solids, all the organic fraction will vaporize, and now you are left with the residue or the fixed solids. So after 2 hours, inside this dish, you will only have the fixed solids left. Now this dish only contains fixed solids. This dish contains only fixed or inorganic solids. Fixed or inorganic total solids. all the volatile solids will vaporize. All the volatile solids will vaporize. Volatile or organic solids, volatile or organic solids, total solids will vaporize from the system. Now the weight of the dish with this fixed or inorganic total solids is given as 50.005 grams. You need to calculate the percentage fraction of volatile solids that are present in the water sample. Means out of these total solids, what is the fraction of organic solids that are present in the water sample? Okay, now this question seems to be very easy. From this data, which is 50.005 grams, I can calculate the quantity of fixed solids or inorganic solids. So let us do that first. So inorganic total solids, inorganic or fixed total solids is equal to weight of crucible plus fixed total solids, which is 50.005. So this is 50.005 minus empty weight of the crucible. So this will going to give you the total weight of fixed solids. Now this total weight of fixed solid is present in 50 ml of the sample. So for 1 liter of the sample, divide by 50, multiply by 1000. So this will going to give me the answer in gram per liter. So when you solve this quantity, you will get inorganic or fixed solids. Please calculate and tell me what is the value of inorganic or fixed solids. Inorganic or fixed total solids, you will get from here as 0.1 gram per liter. 0.1 gram per liter, right? You have the value of total solids. You have the value of inorganic total solids. You can calculate the value of organic total solids. From this relation, total solids is equal to inorganic total solids. Inorganic total solids plus organic total solids plus organic total solids. Same, these organic total solids are also known as volatile total solids. So this is nothing but volatile total solids. Volatile total solids, right? Substitute the value. Total solids is 0.4. Inorganic is 0.1 plus organic total solids. I am writing in short. Organic total solids comes out to be 0.3 milligram per liter. Sorry, 0.3 gram per liter. Organic total solids comes out to be 0.3 gram per liter, right? Now you need to calculate the percentage fraction of the organic total solids. This percentage fraction is calculated with respect to the total solids. So percentage fraction of volatile total solids is equal to organic total solids divided by total solids multiply by 100. So this is the percentage fraction of volatile total solids, right? Just substitute the value. Organic total solid is 0.3. Total solid is 0.4. Please take care of the units. Both organic total solids and total solids are measured in gram per liter. So this is 0.3 divided by 0.4 multiplied by 100. So percentage fraction of volatile total solids comes out to be 75%, right? Now there can be 4 varieties of this question. This is the first variety where you are asked to calculate the percentage fraction of volatile solids. The same question can be framed to calculate the percentage fraction of fixed solids. So that also we can calculate percentage fraction of fixed solids percentage fraction of fixed total solids is equal to inorganic total solids divided by total solids into 100. So this is equal to 0.1 divided by 0.4 multiplied by 100. So this comes out to be 25%. So this is your percentage fraction of fixed solids, right? So either you are asked to calculate the percentage fraction of the organic solids or volatile solids, or percentage fraction of fixed solids or inorganic solids, or their individual concentration can also be asked, right? These are the individual concentration. This is the concentration of organic total solids and this is the concentration of inorganic total solids. So one question can be asked in 4 ways. And absolutely this type of question will be asked for 2 marks. So please keep a check. I hope you have understood the solution. So again, this was a question which is directly framed from the test of total solids, right? We take the water sample, we place it in oven at 104 degrees Celsius, where all the water will evaporate and you are left with total solids. Now this oven dried sample is placed inside the muffle furnace at 550 to 600 degrees Celsius for the duration of 2 hours, where all the volatile fraction of the solids will vaporize and you are left with the residue or the fixed solids, right? So basically, if the questions are framed from the total solids, the entire experiment is written in the form of a question like this. So please keep a check on that, right? So this is the question from total solids. Now moving on to our next question. Okay. So this is the question from pH. Just try this question. Again, I'll give you a timer for 1 minute to try this question. And your time starts now. Please try this question. Please keep commenting your answer and share as much as possible with your colleagues. Please keep commenting your answer in the live chat. Keep commenting your answer in the live chat. Okay, let's see this. So this is the question from pH. My dear students, if the question will be asked from pH, it will be asked from the basic definition of pH. Okay. First of all, what is the basic definition of pH? So pH is basically the scale to measure the acidity or basicity of the water sample or any sample, right? pH is a scale to measure acidity or basicity of the sample. Now this pH is calculated based on the hydronium ion concentration, which is the H plus ion concentration. So pH is negative log to the base 10 of H plus ion concentration, and this H plus ion concentration is always kept in moles per liter. Most of the students make a mistake while substituting the value of H plus ion concentration. This H plus ion concentration is always kept in moles per liter. This is always kept in moles per liter. So this is the first definition. What do you mean by pH? pH is negative log to the base 10 of H plus ion concentration. Okay. Second thing, there is one more scale which is known as pOH. Again, this is also the scale to measure the basicity and acidity of the water sample. pOH can be calculated as negative log to the base 10 of OH minus ion concentration. Again, this OH minus ion concentration is kept in moles per liter. It is kept in moles per liter. It is kept in moles per liter. Out of excitement, what student does is, they see this H plus ion concentration in milligram per liter and they directly place this H plus ion concentration in milligram per liter and make a mistake. No, this H plus ion concentration for calculating pH has to be kept in moles per liter. Similarly, for calculating pOH, this OH minus ion concentration has to be kept in moles per liter. So this is the first definition. Second definition is termed as the ionic product. Second definition is termed as the ionic product of water. As per ionic product of water, H plus ion concentration in moles per liter multiplied by OH minus ion concentration again in moles per liter is equal to 10 raised power minus 14. Both these concentration H plus ion and OH minus ion are to be kept in moles per liter. Both these concentrations are to be kept in moles per liter. So this is my second definition. The third definition is relation between pH and pOH. So pH plus pOH is equal to 14. pH plus pOH is equal to 14. So these are the basic definitions from where the questions from pH are framed. If you remember these four definitions, that is how we define pH, how we define pOH, what is the ionic product, that is H plus ion concentration multiplied by OH minus ion concentration is 10 raised power minus 14. And last one is pH plus pOH is equal to 14. I can guarantee this, you can attempt any question related to pH. Okay, only thing is you need to know how we calculate this mole per liter. Okay, let's start with this question. An effluent from industry A has hydrogen ion concentration as 3.162 into 10 raised power minus 5 moles per liter. So directly the effluent which is coming out from industry A, we know the H plus ion concentration and it is in moles per liter. The effluent from another industry B has triple the hydroxyl ion concentration than the effluent from industry A. Okay, so I'll just divide this question. There are two industries. This is industry A and this is industry B. Two things are given to us. First, H plus ion concentration for industry A is 3.162 into 10 raised power minus 5 moles per liter. Moles per liter. 3.162 into 10 raised power minus 5 moles per liter, right? Second thing which is given to us as OH minus ion concentration for industry B. OH minus ion concentration for industry B is 3 times the OH minus ion concentration for industry A. Okay. And then you are asked to calculate pH of the effluent which is coming out from industry B. Now I think you can very easily solve this question. You need to calculate pH of the water sample which is coming out from industry B. Okay. If you need to calculate pH of the effluent which is coming out from industry B, you need to know the H plus ion concentration for industry B. You need to know the H plus ion concentration for industry B. Now, how to get this H plus ion concentration from industry B? If you know the H plus ion concentration, OH minus ion concentration from industry B, you can use the ionic product and calculate this H plus ion concentration. Now, this OH minus ion concentration from industry B is 3 times of OH minus ion concentration for industry A. And this we can calculate by using the H plus ion concentration for industry A. So let's solve this question. So for industry A, H plus ion concentration for industry A multiplied by OH minus ion concentration for industry A is 10 raised to power minus 14, right? H plus ion concentration I know, this is 3.162 into 10 raised to power minus 5 moles per liter multiplied by OH minus ion concentration is equals to 10 raised to power minus 14. When you solve this, you will get the OH minus ion concentration in moles per liter for industry A, right? So when you solve this, you will get OH minus ion concentration for industry A comes out to be 3.162 into 10 raised to power minus 10. Just quickly cross check this answer. I think this is the correct answer. 3.162 into 10 raised to power minus 10 moles per liter. Moles per liter. So this is the OH minus ion concentration for industry A, right? Once we get the OH minus ion concentration for industry A, I can calculate OH minus ion concentration for industry B. So OH minus ion concentration for industry B is 3 times the OH minus ion concentration for industry A. So this is equal to 3 into 3.162 into 10 raised to power minus 10 moles per liter. So from here, the OH minus ion concentration for industry B, I have already calculated this. See, OH minus ion concentration for industry B is 9.486. So OH minus ion concentration for industry B comes out to be 9.486 into 10 raised to power minus 10 moles per liter. So this is my OH minus ion concentration for industry B. Now, from this OH minus ion concentration for industry B, I can calculate the H plus ion concentration for industry B. So using the ionic product for industry B, H plus ion concentration for industry B multiplied by the OH minus ion concentration for industry B is equal to 10 raised to power minus 14. Substitute the OH minus ion concentration for industry B. So you have H plus ion concentration for industry B multiplied by 9.468 into 10 raised to power minus 10 is equal to 10 raised to power minus 14. From here you can calculate the H plus ion concentration for industry B, which comes out to be this H plus ion concentration for industry B comes out to be 1.054 into 10 raised to power minus 5 moles per liter. From here you can calculate pH for industry B. So pH for industry B, this pH for industry B is equal to negative log to the base 10 of H plus ion concentration for industry B. So this is equal to minus log to the base 10 of H plus ion concentration for industry B, which is 1.054 into 10 raised to power minus 5 moles per liter, right? So from here you can calculate the pH from industry B, which comes out to be 4.977. So pH for industry B is 4.977. So whenever any question comes with respect to pH, always remember 4 things. First, the definition of pH, the definition of pOH, the ionic product of water. H plus ion multiplied by OH minus ion is 10 raised to power minus 14 and pH plus pOH is 14, right? So this is the question which was framed from pH. Now moving on, try this one. This is a good question. Please try this question. Try this question. It's a very good question from alkalinity. So I hope you have tried this question. Okay, so this is a very, very important type of question, because in this question, the test of titration for alkalinity is directly given to you. The question says that a 400 ml of water sample has initial pH of 10 and 45 ml of 0.02 normal H2SO4 is required to titrate the sample to the pH of 4.5. Now, most of the students, when they read the question, they find it is a very difficult kind of a question, or something like that they interpret from this. But if you remember the test of titration that we did for alkalinity, this question is very easy. Remember, when we did the titration for alkalinity, we used two indicators, phenolphthalein and then we used methyl orange. First, we took the water sample and we added phenolphthalein indicator to it. The pH of the water sample was 10 initially. At a pH of 8.3, you got first color change. Then you added methyl orange indicator and again started the titration. At the pH of 4.5, you got another color change. And at pH of 4.5, your entire titration is completed. The total volume of acid used at pH of 4.5, that you have noted, which comes out to be the M value. This is the M value, volume of acid used. Volume of acid used. Now this total volume of acid used to neutralize all the types of alkalinity that is present in your water sample. It can be a caustic alkalinity, carbonate alkalinity or bicarbonate alkalinity. So in this question, directly it is given that a total of 45 ml of sample of acid, a total of 45 ml of 0.02 normal H2SO4 is used to bring down the pH from 10 to 4.5. It means the total amount of acid which is used to neutralize all the alkalinity present in the water sample is 45 ml. Okay. Now when you know the normality of acid and volume of acid used, this is for acid. The next thing that you did is you calculated the number of gram equivalents of acid, number of gram equivalents of acid, and this is equal to the number of gram equivalents of alkalinity. This is equal to the number of gram equivalents of alkalinity. Now we know this, that alkalinity is represented as CaCO3. So alkalinity as CaCO3 is equal to number of gram equivalents of alkalinity, number of gram equivalents of alkalinity multiplied by the equivalent weight of CaCO3. Multiplied by the equivalent weight of CaCO3. So this is how we calculated the total alkalinity which is present in our water sample. So let's start with this. I'll start step by step. So volume of the sample is 400 ml. Volume of sample is 400 ml. Next, volume of acid used, or volume of 0.02 normal H2SO4, which is an acid, used is 45 ml. Okay. And this is the total quantity of acid used to bring down the pH from 10 to 4.5. Then, number of gram equivalents of acid used. Number of gram equivalents of 0.02 normal H2SO4 used is equal to normality of acid, which is 0.02, normality of acid, which is 0.02, multiplied by volume of acid used, which is 45 ml. So I'll convert this in liter by multiplying it with 10⁻³ Now these are the number of gram equivalents of acid used to neutralize alkalinity present in 400 ml of sample. So for 1 liter of sample, you need to divide by 400 and multiply by 1000. So this is the total number of gram equivalents of acid used, which is used to neutralize the alkalinity present in 1 liter of the sample. Thank you so much. Okay, chalo, moving on with this. So number of gram equivalents of acid used, number of gram equivalents of 0.02 normal H2SO4 used is equal to number of gram equivalents of alkalinity present. Number of gram equivalents of alkalinity present. Now we know the number of gram equivalents of acid used, which is this much, which is equal to the number of gram equivalents of alkalinity. So number of gram equivalents of alkalinity, is equal to 0.02 into 45 into 10 raised power minus 3 divided by 400 multiplied by 1000. So this is the number of gram equivalents of alkalinity. Now the number of gram equivalents of alkalinity we know. We can calculate alkalinity as CaCO3. So alkalinity of the water sample as CaCO3. Alkalinity of the water sample as CaCO3 is equal to number of gram equivalents of alkalinity, which is this much, 0.02 into 45 into 10 raised power minus 3 into 1000 divided by 400. So this is the number of gram equivalents of alkalinity multiplied by the equivalent weight of CaCO3. So equivalent weight of CaCO3 is molecular weight of CaCO3. Molecular weight of CaCO3 is 100 divided by the valency of CaCO3, which is 2. So equivalent weight of CaCO3 is the molecular weight of CaCO3, which is 100 grams divided by the valency, which is 2. So from here you will get alkalinity as gram per liter as CaCO3. When you solve this, you will get alkalinity as gram per liter as CaCO3. Now this 10 raised power minus 3 and this gram, when you combine this, this will be milligram. And when you solve this, you will get the final answer in milligram per liter as CaCO3. So I have already done this calculation. This total alkalinity comes out to be 102.5 milligram per liter. So alkalinity as CaCO3 comes out to be 112.5 milligram per liter as CaCO3. So basically what happens is alkalinity is caused by all the anions which are present in the water sample. Majorly OH minus ions, HCO3 minus ions and CO3 minus ions contribute to the total alkalinity of the water sample. So either you represent concentration of individual ions, that doesn't make that much sense. So what we do is we calculate number of gram equivalents of all the ions and then we multiply it with the equivalent weight of CaCO3 to get the total alkalinity of the water sample as CaCO3. Okay. So this is just one of the way in which we solve this question. So I hope you have understood this question, because in this question the catch point was understanding this test or understanding the titration which we do for calculating the alkalinity of the water sample, right? Now moving on with this, try this question. This is the question from hardness. Again a very simple question. You need to check what all things are given and what you need to calculate. Again I'll keep a timer for 1 minute and you can solve this question in that time. This is the timer for 1 minute for this question and your time starts now. Just try this question. Okay. So whenever a civil engineering student see these type of questions which involve a bit of chemistry, okay, they usually leave these type of questions. But these are the questions which are very easy. They are like very easy if you understand the terms that we use. Question says that a water sample analysis data is given below. Means a sample of water is analyzed in which we get 3 ions. First one is the calcium ion, then we have magnesium ion, and then we have bicarbonate ion. The concentration of calcium ion is 60 milligram per liter. The concentration of magnesium ion is 30 milligram per liter, and concentration of bicarbonate ion is 400 milligram per liter. Okay. Then the atomic weight of all these ions are given to us. The carbonate alkalinity expressed as milligram per liter of CaCO3 up to 1 decimal place for the water sample is. Okay, so you need to calculate the carbonate alkalinity of, carbonate hardness of the water sample. Okay, you need to calculate the carbonate hardness of the water sample. For this type of question, first thing you need to understand, what do we mean by alkalinity and what do we mean by hardness? Just follow this table. Whenever you are asked to calculate alkalinity, you need to focus on 3 ions, OH minus ions, CO3 2 minus ions, and HCO3 minus ions. Okay, whenever you are asked to calculate alkalinity, you need to focus on 3 ions. OH minus ions, CO3 2 minus ions, and HCO3 minus ions. These are the major ions causing the alkalinity. These are the major ions causing the alkalinity, right? These are the major ions causing the alkalinity. Alkalinity is the property of anions, negatively charged ions. It is the acid neutralizing capacity of water. So basically all the anions provide alkalinity to the water. But for our calculation, we focus on 3 major ions, OH minus ions, CO3 2 minus ions, and HCO3 minus ions. On the other hand, if I talk about hardness, so hardness is majorly caused by calcium 2 plus ions and magnesium 2 plus ions. So these are the major ions which cause the hardness in water. These are the major ions which cause the hardness in water. Again, hardness is the property of multivalent cations, that is having +2 or +3 charge. Okay. But majorly when we calculate hardness in the water sample, we only consider calcium 2 plus ions and magnesium 2 plus ions. Okay, because these are the major ions causing the hardness in water. So we need to focus on 5 ions basically, 3 for alkalinity and 2 for hardness, that's all. Whenever any question in such type is asked in your examination, you have to look into first, what are the ions that can cause hardness? So calcium and magnesium ions are there which can cause hardness. There is one more ion, HCO3, which can cause alkalinity of the water sample, right? And you are asked to calculate the carbonate hardness of the water sample. So I'll give you one simple relation. Usually students get into the details of it and confuse themselves, but I'll directly make the note point. And that note point is carbonate hardness is equal to minimum of total hardness is equal to the minimum of total hardness or alkalinity. You need to calculate total hardness and alkalinity of the water sample. The minimum value of total hardness and alkalinity will be equal to the carbonate hardness. As simple as that. Okay. You need to remember this note point directly, because sure shot, you will get a question in your exam with respect to this note point. The minimum of total hardness and alkalinity will be equal to carbonate hardness, that's all. Now we will see this question. Now we are given with 3 ions. We know that calcium ions and magnesium ions will cause the hardness of the water sample. Okay, so we will calculate the total number of gram equivalents of hardness. So number of gram equivalents of hardness, number of gram equivalents of total hardness, TH I am writing, is equal to number of gram equivalents of calcium ions and magnesium ions. Number of gram equivalents of calcium ion and magnesium ion. Number of gram equivalents of calcium ion is equal to the given weight of calcium ion. Given weight of calcium ion divided by the equivalent weight of calcium ion. Divided by the equivalent weight of calcium ion. Similarly, number of gram equivalents of magnesium ion is equal to the given weight of magnesium ion. Given weight of magnesium ion divided by the equivalent weight of magnesium ion. Divided by the equivalent weight of magnesium ion. So this is how we calculate the number of gram equivalents of total hardness, which is equal to number of gram equivalents of calcium ion plus number of gram equivalents of magnesium ion. Now the given weight of calcium is 60 milligram per liter. Please check on the units. So 60 milligrams, so 60 into 10 raised to power minus 3. So now this will be in gram per liter. Divided by the equivalent weight of calcium ion. So equivalent weight of calcium ion is the atomic weight of calcium ion, which is 40 gram, divided by the valency of calcium ion, which is 2. So this will be the number of gram equivalents of calcium ion, given weight divided by the equivalent weight. Equivalent weight is atomic weight or molecular weight divided by the valency. If it's a molecule, it will be molecular weight. If it's an atom, it will be the atomic weight. Calcium is an atom, therefore atomic weight. Similarly, the number of gram equivalents of magnesium ion is equal to the given weight of magnesium ion, which is 30. And this is in milligram per liter. So 30 into 10 raised to power minus 3 gram per liter. Divided by the equivalent weight of magnesium ion, which is atomic weight of magnesium 24 divided by the valency of magnesium, which is 2. You have to just look into this plus 2 or plus 1 charge. That will be the valency of that particular ion. We as a civil engineer, we need not to go into the depth of valency, because again, for going into the depth of valency, you need to go back for your 11th class. And there the huge number of exception comes. So for us in civil engineering, either the valency will be 1 or valency will be 2. If it's iron 3 plus, then valency will be 3. That's all. Okay. So for us, the things are very easy. Either the valency is 1 or the valency is 2. You need to check on the charge present over the ion, and that will be the valency for us. Okay. So these are the number of gram equivalents of total hardness. Now total hardness as CaCO3, total hardness as CaCO3 is equal to number of gram equivalents of hardness, number of gram equivalents of hardness, number of gram equivalents of total hardness multiplied by the equivalent weight of CaCO3. Multiplied by the equivalent weight of CaCO3, right? So this will going to give us the concentration of total hardness as CaCO3. Thank you. Hi Shankar. Okay, so this will give the total hardness as CaCO3. So number of gram equivalents of total hardness multiplied by the equivalent weight of CaCO3. Please try this. So number of gram equivalents of total hardness we have calculated, multiplied by the equivalent weight of CaCO3, we can calculate the total hardness. So total hardness is equal to equivalent weight of, number of gram equivalents, which is 60 into 10 raised power minus 3. 60 into 10 raised power minus 3 divided by 20 plus 30 into 10 raised power minus 3 divided by 12. 30 into 10 raised power minus 3 divided by 12. So this is the number of gram equivalents of hardness multiplied by the equivalent weight of CaCO3. So molecular weight of CaCO3 is 100 divided by the valency of CaCO3, which is 2. Now you will feel, sir, how the molecular weight of CaCO3 is 100. So CaCO3, calcium is 40, carbon is 12, oxygen is 16 into 3. 16 into 3. So when you add this, you will get the total weight as 100 grams. So this is the molecular weight of CaCO3, which is 100. Valency of CaCO3 is 2. So divide by 2. So this will going to give me the total hardness concentration. Please calculate this and tell me. This will be the total hardness as CaCO3 in gram per liter. Gram per liter as CaCO3. So again you can take this 10 raised power minus 3 common and combine it with gram. So you will get milligram per liter as CaCO3. Just do the calculation for this. So this is 60 by 3, 60 by 20, which is 3, plus 30 by 12. So this is 30 by 12 multiplied by 50. So you will get the answer in milligram per liter as CaCO3. Just do this calculation and let me know the answer. Just do this calculation quickly and let me know the answer for this. Hi to all, we are solving excellent questions that are expected in GATE 24. Please share this session as possible because we are dealing with some exceptionally good questions that are expected in GATE 24. Just quickly calculate this and tell me the answer for total hardness as CaCO3. So this comes out to be 275 milligram per liter. So total hardness comes out to be 275 milligram per liter as CaCO3. So this is the value of total hardness. So this is how we have calculated the total hardness, right? Now step number 2 is calculating the value of alkalinity. So when you come back to the question again, you will find that there is only one ion, HCO3 minus ion, that is causing the alkalinity. The amount of HCO3 minus ion present is 400 milligram per liter. So we can calculate number of gram equivalents of alkalinity. So number of gram equivalents of alkalinity, is equal to number of gram equivalents of HCO3 minus ion. So number of gram equivalents of HCO3 minus ion is the given weight of HCO3 minus ion, which is given as 400 milligram per liter. So 400 into 10 raised power minus 3 divided by the equivalent weight of HCO3 minus ion. So again the valency of HCO3 minus ion is 1 and molecular weight of HCO3 minus ion is directly given to us, which is 61. So this is the number of gram equivalents of HCO3 minus ion. From here, I can calculate alkalinity as CaCO3, which is equal to number of gram equivalents of alkalinity, number of gram equivalents of alkalinity multiplied by the equivalent weight of CaCO3. So number of gram equivalents of alkalinity is known to us, which is 400 into 10 raised to power minus 3 divided by the equivalent weight of HCO3 multiplied by the equivalent weight of CaCO3, which is 50. 100 by 2, this we have already done. So from here you will get the concentration of alkalinity in gram per liter as CaCO3. So when you combine this 10 raised to power minus 3 with gram, this will be in milligram per liter. Just solve this to get the concentration of total alkalinity. So alkalinity comes out to be 327.86 milligram per liter as CaCO3. 327.86 milligram per liter as CaCO3. This is my total alkalinity, right? 327.86 is my total alkalinity and 275 milligram per liter as CaCO3 is my total hardness. Now I'll write all this. So total hardness is 275 milligram per liter as CaCO3 and total alkalinity is equal to 327.86 milligram per liter as CaCO3. So let me check this once again. So this is 275, this is 327.86. Now in the question you are asked to calculate the carbonate hardness of the water sample. We have already seen a relation that carbonate hardness is equal to minimum of total hardness and alkalinity. So now the only thing that you need to do is just compare total hardness and alkalinity. You need to compare total hardness and alkalinity, and it is clearly visible that out of total hardness and alkalinity, total hardness is less. So we can write carbonate hardness is equal to minimum of total hardness or alkalinity. So out of total hardness and alkalinity, total hardness is minimum. So from here I can write total hardness is equal to 275 milligram per liter as CaCO3. So for this question, carbonate hardness is equal to 275 milligram per liter as CaCO3. These type of questions are again one of the favorite questions of not just GATE, all the technical exams that are conducted in the country. Now there is one more variety to this question. Here we have calculated the carbonate hardness. The question can also be framed to ask about non-carbonate hardness. So from here we know carbonate hardness is equal to 275 milligram per liter as CaCO3. Now if you want to calculate the non-carbonate hardness for this question, use this relation. Total hardness is equal to carbonate hardness plus non-carbonate hardness. Total hardness is equal to the carbonate hardness, so these two cancels out. So for this question, non-carbonate hardness is equal to 0. So again, these varieties can be framed from this question. Okay. Carbonate hardness is asked that we have calculated as 275. That is our answer. Now another variety for the same type of question can be calculate the non-carbonate hardness. So non-carbonate hardness is total hardness minus carbonate hardness. From there we can calculate the non-carbonate hardness. Okay. So again, this is a very, very important question. See one more variety of the same question, which is framed from calculating the total hardness. So this is the question which was asked for 4 marks, and many variety of this question was already asked in the GATE examination. A water sample analysis data is given to you. You know calcium, magnesium, sodium, bicarbonate, sulfate, chloride. All these ions are present and the concentration of all these ions are also given to you. Then you are also given with the atomic weight of all these ions. You need to calculate the total hardness as milligram per liter of CaCO3, and you also need to calculate the carbonate hardness of the water sample. Whenever you see carbonate hardness or non-carbonate hardness, always remember, you need to calculate total hardness and alkalinity, and from there, you need to calculate the value of carbonate hardness. And using carbonate hardness, you can calculate non-carbonate hardness. Okay. Please keep a check on this. Again, I'll keep a timer for 1 minute. Try this question. So here is a timer for 1 minute. Try this question. Again, it's a very simple question. If you know that relation between carbonate hardness, total hardness and alkalinity, please try this. Okay, let's see this question. You need to calculate the total hardness. We know that total hardness is caused by all the multivalent cations, but the major ions that cause the hardness in the water sample is calcium ion and magnesium ion. Okay. Total hardness is equal to number of gram equivalents of total hardness multiplied by the equivalent weight of CaCO3. So step 1 is calculate the number of gram equivalents of total hardness. Number of gram equivalents of total hardness, which is equal to number of gram equivalents of, calcium ions plus magnesium ions, right? When you look into the question, there is one more ion, sodium, is also given to you. Sodium will not cause any hardness because sodium is a univalent, have +1 charge. For hardness, you require +2 or +3 charge. Multivalent ions are required, right? So sodium will not cause any hardness to your water sample. Only hardness will be present due to calcium ion and magnesium ion. Okay. So let's solve this. Calcium is 100 milligram per liter and magnesium is 6 milligram per liter. So number of gram equivalents of calcium ion is given weight of calcium, which is 100 milligram per liter. So 100 into 10 raised power minus 3 divided by the equivalent weight of calcium ion, which is the atomic weight divided by valency. So this is the number of gram equivalents of calcium ion. Now number of gram equivalents of magnesium ion is the given concentration, 6 milligram per liter. So 6 into 10 raised power minus 3 divided by the atomic weight of magnesium, which is 4, and valency of magnesium is 2. So this is the number of gram equivalents of total hardness. Now total hardness is equal to number of gram equivalents of total hardness multiplied by the equivalent weight of CaCO3. So total hardness is equal to number of gram equivalents of total hardness multiplied by the equivalent weight of multiplied by the equivalent weight of CaCO3. So number of gram equivalents of total hardness we have already calculated. This is 100 into 10 raised to power minus 3 divided by 20 plus 6 into 10 raised to power minus 3 divided by 12 into equivalent weight of CaCO3. So equivalent weight of CaCO3 is molecular weight of CaCO3, which is 100, divided by the valency of CaCO3, which is 2. So this is 100 divided by 2. So from here you will get the concentration in gram per liter as CaCO3. Okay. Now again, if you take this 10 raised to power minus 3 common and you combine it with gram, so this will be milligram per liter. So just do the calculation and get me the concentration of total hardness in milligram per liter as CaCO3. Just try this one. So from here, the total hardness comes out to be 275 milligram per liter as CaCO3. Total hardness comes out to be 275 milligram per liter as CaCO3. This will be my total hardness of the water sample, right? So this is the step number 1 where we have calculated the total hardness. Now coming to the next step, which says that calculate the carbonate hardness of the water sample. Now for calculating the carbonate hardness, we need to know the alkalinity of the water sample. And the major ions which cause the alkalinity are OH minus ions, HCO3 minus ions and CO3 2 minus ion. So we have HCO3 minus ion given to us and concentration is 250 milligram per liter, right? So we can calculate the concentration of alkalinity. So number of gram equivalents of alkalinity, number of gram equivalents of alkalinity is equal to number of gram equivalents of HCO3 minus ions, right? Number of gram equivalents of HCO3 minus ion is the given weight of HCO3 minus ion. Given weight of HCO3 minus ion is 250. Given weight is 250 milligram per liter. So 250 into 10 raised to power minus 3 milligram per liter divided by the equivalent weight of HCO3, which is the molecular weight divided by the valency. So molecular weight of HCO3 is 61 divided by the valency of HCO3, which is 1. So these are the number of gram equivalents of alkalinity. Now alkalinity as CaCO3 is equal to number of gram equivalents of alkalinity multiplied by equivalent weight of CaCO3 okay. So number of gram equivalents of alkalinity is this much. This is 250 into 10 raised to power minus 3 divided by 61 multiplied by the equivalent weight of CaCO3, which is 50. So from here you will get the concentration in gram per liter as CaCO3. Now again this 10 raised to power minus 3 in gram will be milligram per liter, and from here you will get the concentration of alkalinity, which comes out to be 204.91. Alkalinity comes out to be 204.91 milligram per liter as CaCO3. So this is my alkalinity, and earlier we have calculated the total hardness. So again I write this. Total hardness is equal to (275) milligram per liter as CaCO3, and alkalinity is equal to 204.91. milligram per liter as CaCO3. So from here I can calculate carbonate hardness. So carbonate hardness is minimum of total hardness and alkalinity. So when you see total hardness and alkalinity is less. So carbonate hardness will be equal to 204.91 milligram per liter as CaCO3. So in the first part you need to calculate the total hardness. In the second part you were asked to calculate the carbonate hardness of the water sample. So carbonate hardness we have calculated, total hardness we have also calculated. Now again one more variety can be framed, calculating the non-carbonate hardness. So we can write this total hardness is equal to carbonate hardness plus non-carbonate hardness. So total hardness is 275, carbonate hardness is 204.91 plus non-carbonate hardness. So non-carbonate hardness is equal to 275 minus 204.91, and this will come in milligram per liter as CaCO3. Milligram per liter as CaCO3. So these are all the possibility of questions that can be framed from this topic. So this is the question where we are required to calculate the carbonate hardness and the total hardness. So I hope you have understood this solution. Okay. Okay. Now this is again a GATE previous year question, again based on the same concept. Just try this. The alkalinity and the hardness of the water sample are 250 milligram per liter and 350 milligram per liter as CaCO3. The water has, you need to find the relation between carbonate hardness and the non-carbonate hardness. So I will write here, alkalinity is 250, alkalinity of the water sample is 250 milligram per liter as CaCO3, and total hardness is equal to 350 milligram per liter as CaCO3. Okay. This is 250 milligram per liter as CaCO3 and this is 350 milligram per liter as CaCO3. Now carbonate hardness is the minimum of total hardness and alkalinity. Carbonate hardness is minimum of total hardness and alkalinity. So when you look into total hardness and alkalinity, alkalinity is less, which is 250 milligram per liter as CaCO3. So carbonate hardness is equal to 250 milligram per liter as CaCO3. This is the carbonate hardness. Now once you know the carbonate hardness, you can calculate the non-carbonate hardness. So non-carbonate hardness is equal to total hardness minus carbonate hardness. Total hardness is 350 and non-carbonate hardness is 250. Sorry, carbonate hardness is 250. So non-carbonate hardness comes out to be 100 milligram per liter as CaCO3. So when you look into these options, so carbonate hardness is 250 milligram per liter as CaCO3. So all B, C, D, you have 250 only. But non-carbonate hardness is 100. So for this question, option number D is correct. Option number D is correct. This was the question which was asked in GATE examination. So we have covered majority of the concepts that are asked from the raw water quality parameters, right? I hope you have found this session useful. If you look into the details of this session, you will find that we precisely focus in three areas. First one is total solids, second one is pH, third one is the relation between alkalinity and hardness. And these three are the main areas where you will find all the previous year questions. Majority of the previous year questions are framed from these areas, especially the numerical answer type questions. So I hope this session was useful. Please continue watching to the further sessions for the excellent questions of environmental engineering. And again, I'll come back again for the excellent question series of environmental engineering from the next topic. So thank you so much for today. This is all for today. I'll see you in the next session. Thank you so much.